to our November UNH Sustainability Alumni webinar. I'm Fiona Wilson, and I have the honor of serving as UNH's Deputy Chief Sustainability Officer and as Director of our Sustainability Institute. I'm really excited for today's conversation with three amazing UNH alums who I will introduce momentarily. Also co-hosting with me today is my colleague, Alexis Dwyer. She's our Alumni and Network Stewardship Coordinator here at the Sustainability Institute, and you're going to hear more from Alexis later on today. We're really pleased to partner with UNH Alumni Relations to bring this year-long Alumni Sustainability webinar series to our community, because we know that we have hundreds of UNH alums from across the decades who are working in sustainability-related fields and who have deep expertise and really valuable perspectives on these topics. And we also know that there are thousands more alumni who don't perhaps work in the field of sustainability, but who are interested in the topic. So we really designed these webinars to allow you to hear from UNH alums who are leading experts in sustainability across industries and sectors. And today, as in each of the webinars, these alums are going to be sharing some diverse perspectives on key trends. You'll hopefully gain some practical knowledge that you can use both professionally and personally. If you go to the next slide, please, Alexis. And next slide again, thank you. UNH is a very fitting host for this webinar series as a national leader in sustainability in higher education. We were only the third university to achieve a platinum rating in STARS a few years ago. And today we're one of only 11 universities that has that highest level of recognition. STARS, or the Sustainability Tracking Rating and Assessment System, is a rigorous reporting platform that measures all aspects of how sustainability is incorporated across a university's curriculum, operations, research, and community engagement. And before I introduce our alumni speakers today, I wanted just to share a couple of quick, tangible examples of UNH's work in sustainability, specifically today about our work on sustainable transportation. We see this as a really important opportunity to address the climate crisis, and as part of our WildCap, our climate action plan here at UNH, but really only if it's done thoughtfully and in combination with our continued efforts to also reduce energy use on campus and add renewable energy to our grid. Electrifying UNH's fleet of campus and transit vehicles is definitely an important priority, and so we've begun a long-term plan for that transition, being led by our colleagues in the transport group at UNH. It's definitely going to require significant investment, not only in vehicles, but also, of course, in supporting charging infrastructure. But if we do it well, a transition to EV buses will have a co-benefit for our overall campus energy system by providing options for enhanced energy storage. That's because electric buses have the potential to act like big batteries for energy produced in our campus cogeneration plant. And as part of that transition, we've also applied for grant funds, and electrifying our fleet is going to be a big job and strategically needs to be our first priority because it's our best opportunity to maximize transportation-related greenhouse gas reductions. That said, we're also beginning to explore and map the path for build-out of public charging infrastructure for students, employees, and campus visitors. Since UNH is a unique university in that we generate and distribute power across parts of campus, and that we're connected to the grid, this presents a lot of complexities because anything that we do on campus will affect our entire energy system. Next slide, Alexis. So that's one of the reasons why collaboration is so key. UNH is working really closely with the town of Durham and deliberately and carefully working within UNH's Energy Task Force and also the UNH Transportation Policy Committee, as well as electric and third-party vendors, to make sure we're really balancing the need for equity, accessibility, reliability, and affordability as we tackle this challenge. So moving into today's topic, before I introduce the speakers, just wanted to note that we'll have plenty of time for questions from the audience towards the end of today's webinar, in the second half of the webinar. So we encourage you to start putting your questions for the panelists into the Zoom Q&A webinar function at any time. So put your question in as we're going through, you'll get your question in queue. And now let me introduce our speakers. Today's webinar is a topic high on many of our minds, I think. As we know, transportation accounts for almost 30% of total US greenhouse gas emissions, making it the largest contributor to US greenhouse gas emissions overall. And as the urgency of the climate crisis becomes ever more apparent, the automotive industry is, of course, accelerating their transition to EVs, electric vehicles. But at the same time, there are many complexities and issues remaining, and we'll talk about some of those. I'm excited for this conversation. Three incredible alumni here. They really span. We've got leaders who have worked for some of the largest automakers in the world. We've got consultants, we've got entrepreneurs, we've got innovators and inventors. So it's going to be a very rich conversation. So I'm really delighted to introduce you to John Stech, who is currently the founder and principal of ShiftGate Consulting. Daniel Zuby, who is an entrepreneur and an innovator, an inventor. And last but no means least, and somewhat confusingly, another Daniel with a Z, Daniel Zotos. He is currently Senior Manager of Public Affairs and Advocacy for a very interesting company called Redwood Materials. So welcome, John and Daniel squared. So happy, Daniel Z squared. Not often that, yeah, I imagine you're in rooms where there are two Daniel Z's, but we're delighted to have you both, as well as you, John. So love just to ask you to quickly do a very quick introduction, a minute or two each, of your UNH connection, when you graduated, what you majored in, but mostly just a brief description of your background, obviously with a particular emphasis on your experience in the automotive and EV space. So John, let's start with you.
Great. Thank you very much for the introduction, Fiona. I graduated from UNH in 1993 with an MBA. I was a full-time student on campus. It was a great place to earn an MBA. Following that, I spent 30 years in the international automotive industry, where I worked for companies like Mercedes-Benz, Volvo Cars, Chrysler, which is now part of Stellantis. Most recently, I moved to Southeast Asia, where I worked for VinFast, the Vietnamese electric car company, and worked there as the global chief marketing officer. Now I've relocated to Bangkok, Thailand. It's actually midnight here while I talk to you. I did spend the first part of my career selling V8s and V12s, so now I'm trying to make up for that.
Love that. Yeah, thanks so much for being here so late at night on your time. Really appreciate it. Daniel, why don't I go to you, Daniel Zotos, next?
Thanks, Fiona. Daniel Zotos, class of 2014. I was a poli-sci and international relations dual major. Definitely had my first foray into sustainability policy while at UNH. I spent some time with a Hamill Center grant working on environmental policy, particularly international fisheries policy, which was just of personal interest to me. Post-grad, and just by virtue of being in first in the nation primary state of New Hampshire, I did a number of stints on political campaigns, and then found myself closely aligned with clean energy policy, as well as the transition work that's been happening over the past few years pretty aggressively. Was working at a national coalition called the Zero Emission Transportation Association, focused on consumer sentiment and adoption, as well as policies that we've seen go into the bipartisan infrastructure law, as well as the Inflation Reduction Act, all of which has led me to a really cool and innovative company called Redwood Materials, focused on sustainable battery materials production, as well as lithium-ion battery recycling. So we can get into more of that later, but great to be here, especially amongst this panel as well. I think we'll have a great discussion.
Great, thanks, Daniel. And Daniel Zuby, last but not least.
Yeah, thank you again, Fiona and the UNH Sustainability Institute, for putting this on, and kudos to UNH for making all the progress you have in the sustainability space. So that's really awesome, and it's a pleasure to be part of the panel here. I graduated from UNH with my bachelor's in mechanical engineering in 2005, and I went on to get my master's in mechanical engineering with a focus on energy and the environment at Colorado State University 2 years after I graduated from UNH, and then I've been working as a mechanical engineer for the last 15 years, give or take, in research and development, product development for various industries and a bunch of different types of companies. And more recently, in February, I decided to leave my full-time job and start my own company called ModLev, which is stands for Modular Light Electric Vehicle. And I'm trying to, as a lifelong cyclist, I've always been passionate about two-wheeled transport, and so now I'm trying to combine my personal passion with my professional expertise and knowledge to bring a new type of vehicle that will replace passenger vehicles with something that is smaller, more human-sized, lighter weight, and modular. So for most trips, you can take a vehicle that is only big enough for you. That's about 80% of trips. And then for the other times, whenever you need a larger vehicle for whatever reason, you can actually combine these modules together and create a larger vehicle on the spot. And so the end result is something that saves time, saves money, saves energy, and it's better for the environment and better for everyone.
Great, thanks, Daniel. I know we're going to learn a little bit more about your what you're working on a little bit as we go through the webinar today. We thought we'd start with a few lightning rounds, some yes/no questions to sort of put some of those big elephants in the room out there that really exist around like the transition to electric vehicles. So the first question, and we're just going to ask people to do a yes/no, and then we're going to come back and hear a little bit more about why they said yes/no. Are people right to have range anxiety about electric vehicles? Yes or no? John? Oh, you're on. No, yeah, no, yeah.
No.
Yeah, so we'll do John Stetch, Daniel Zuby, and then Daniel Zotos. So John's a no, Daniel's a...
I would say yes.
Daniel Zotos?
I'd say a resounding no.
All right. What about there's a sort of saying that, you know, electric vehicle batteries are bad for the environment. Yes or no? John, then Daniel Zuby, and then Daniel Zotos.
Yes, but with qualifiers.
I agree. Yes, but it depends.
I'll switch it up here and say no, and I can explain why.
Okay, cool. Love it. And then last one, do electric vehicle engines have fires at greater rates than combustion engines? Yes or no? Same order.
A big no with capital letters.
I agree. That's a no.
Unanimous no's on this one.
All right. Well, let's dive in and just do some quick clarifying answers around some of these. So the issue about range anxiety, Daniel Zuby, you want to start on that one?
Yeah, so I said yes on that because if you look at the numbers in the United States, at least, for every 1,000 road miles, there's 104 gas pumps and only 22 EV charging ports. Now, those are just the numbers. It also, there's some other things that you want to include there, which is if you think about, this is why it's kind of a yes/no, but 98% of vehicle trips are less than 50 miles, right? And over half of vehicle trips are less than 3 miles. And so that range anxiety, it's something that can be easily resolved, right? And so take another example, looking at internal combustion engine or ICE vehicles versus EV vehicles, it doesn't have to be an all or nothing thing, right? So almost 60% of households in the US have 2 cars. And so you could replace one of your ICE vehicles with an EV, and you'll start realizing that, okay, you know what? I can actually use this EV, maybe not as my second vehicle, but as my first vehicle, right? And then you can start to switch that up as you start using it more and realize that the range anxiety is not really much of a thing.
Yeah, love it. John or Daniel, anything to add on that clarifying question?
I would say I would agree on the fact that most people drive very low mileage on a daily basis. And if you are a commuter that drives to the same place every day and hardly varies from a daily or a weekly routine, it's very easy to plan in, when you have to charge, how you have to charge. It's only when you do the occasional long trip to an unknown destination where you're not sure what is the charging network on the way to that destination. That's when range anxiety might set in. But on a daily basis, I would say, like Daniel Zotos, it's a resounding no.
Yeah, that's great. Thank you.
And
Go
I'll
ahead.
just add to, I think I spent some time close to consumer sentiment on this, my time at Zeta. I mean, a lot of this is just a behavioral shift for people as well. I mean, we can talk a little more about this later in the session, but of course, public policy is also trying to meet that anxiety and concern with investments from certain federal laws. But this really is a behavioral understanding and shift in terms of what we're used to. And of course, that takes time with technology. But I mean, to what both Daniel and John said, this is about also, a ubiquitous nature of charging, where you might approach things differently than you would have with a traditional ICE vehicle here, where you may have charging access at a kid's soccer game, or quickly fuel up and charge up at convenient locations along a corridor. So there's a lot of work going into this. I also think, of course, it's okay to have anxiety, but I think there's reassurance in terms of response and, comparing the rate of EV adoption to also charging infrastructure and network deployment. I think we're on the right track. It'll take a lot of work.
Yeah, that's great. The question about, are EV batteries bad for the environment? There's been a lot of stuff, in the press about that. And two of you said yes, and one of you said no. So Daniel Zotos, you said no. Like, can you clarify your answer there?
Yeah, well, I guess my answer is really rooted in the work I'm doing every day at Redwood Materials. I think there's a lot of myth busting that does need to occur when it comes to electric vehicles and the environment overall, in terms of life cycle analysis compared to the manufacturing process behind electric vehicle batteries. There's no doubt that extractive mining and the critical minerals necessary for lithium-ion battery technology definitely comes with its concerns. But I'm also just hopeful and optimistic when I look at companies like mine and their focus on a completely circular supply chain when it comes to EV battery metals. At this juncture, Redwood Materials, as well as other companies in this space, have achieved upwards of a 95% materials recovery rate when it comes to critical battery elements, your lithium, cobalt, nickel, etc. And we've also shown and demonstrated equal, if not better, performance from those recycled materials. I mean, while this is early innings right now, the future is very bright in terms of what it looks like for this industry, particularly with recycling, and then, of course, sustainable component production. So in this moment, I think, of course, there will be some growing pains. There's also a massive demand curve of over 1,000% over the next decade in terms of lithium-ion battery demand. We aren't going to recycle our way into addressing that problem immediately. But I think a lot of innovation that's happening right now has pointed us in a really strong direction for, true sustainability when it comes to this sector in a lot of ways. But of course, it's right to have concern. Mining practices should be as sustainable as possible when it comes to this work. But it's also important to look at other solutions and options out there. When we look at lithium-ion batteries overall, there's an enormous opportunity in the consumer electronics market. There are abysmal recycling rates in that space currently, and there is a massive opportunity to capture the value of end-of-life materials from old iPhones, smartphones, power drill batteries, items like that, that can in turn go directly towards electric vehicle batteries. I'll end with one stat. There's enough cobalt in 166 iPhones, for example, to power your standard size Tesla Model Y battery. So when we look at options out there, it's really important to consider, the long game in this entire industry. And, I'm sure, John in particular could probably just even weigh in on the overall OEM response to this, ICE vehicles in general, in terms of energy efficiency and how much of that energy actually reaches the vehicle wheels compared to what starts in the tank. There's a lot of ways to skin the cat overall, but I would just say my overall input here is far from perfect right now, but the work that's going into this is really encouraging.
Yeah, no, thank you. John, why don't we go to you and the question about, do EV engines have fires at greater rates than traditional internal combustion engine vehicles, ICE vehicles? Maybe I'll ask you to address that one, and if you have anything to add on to what Daniel Zota says about batteries as well, feel free to jump in there as well.
Sure, of course. As I said, I got obtained my master's degree at UNH. My undergraduate degree is in chemistry, so I'm a science nerd and I like numbers and data. So I usually let the numbers talk. And when you look at the numbers on fires, you'll find that battery electric vehicles have 25 fires for every 100,000 cars sold. If you look at internal combustion engine vehicles, gasoline or diesel, those are going to have about 1,500 fires for every 100,000 vehicles sold. And then if you look at the combination, the hybrid vehicles, which carry both a battery and a combustion engine, those have 3,500 fires per 100,000 vehicles sold. So you can see there's a huge discrepancy with the battery electric vehicles. It just looks really good in the news and on memes and in social media to post burning electric cars, even though the data would tell you that we should be seeing, hundreds of times many more memes about gasoline cars on fire. So always let the data do the talking.
Love that. Well, let's sort of pivot and just start to think about sort of where we are in sort of big picture. We did a little bit of myth busting there, a little bit of dialogue around that, but let's start to think about sort of where we are and sort of where we're headed in this space. So 2 or 3 words only from each of you, in addition to some of the things that we've just talked about. What are some of the things that are top of mind for you as sort of the biggest issues and or opportunities in the EV space? Daniel Zotos, why don't we go to you first?
I mean, I'll just start by saying global competitiveness here in the United States comparatively. I mean, a lot of what Redwood Materials is focused on is really onshoring the domestic supply chain. I think there's a lot of conversation around supply chain in general in the post-COVID world that's thrown around, but we've realized, through various chip shortages, et cetera, that we are overly reliant on Asia for a lot of what the automotive manufacturing industry looks like here in the United States, while at the same time, and rightfully so, we are building an ascendant industry from the ground up here when it comes to battery manufacturing. But at this juncture, we are still really in the early innings of what that looks like. There's, of course, enormous economic incentive and public policy right now, particularly with the Inflation Reduction Act, when you look at production tax credits, as well as the clean vehicle credit, and a lot of work that went into incentivizing domestic production for battery materials, key components, particularly cathode active materials and anode that go into battery cells. So there's a really exciting future for the United States there, but it's also something we really need to get right in terms of this moment. I don't think it's done and dusted, so to say, in this moment. There's a lot of work that needs to continue. And, China continues to really have a stranglehold on the overall supply chain here when it comes to the refining of battery materials that will ultimately end up in a battery cell. So that's, the overall global competitiveness piece, I think, is good, because this is what also drives down costs for electric vehicles, and particularly for the batteries that power them, which in turn increases adoption, accelerating this entire movement.
Yeah, no, absolutely. Well said, Daniel. John, how would you answer that question? What are some of the things that are top of mind for you as the biggest issues or opportunities in the EV space right now?
Sure. Speaking from a consumer perspective, probably the biggest issue is conflicting information or disinformation. Just a few minutes ago, you have 3 people here on the panel who didn't have unanimous answers to 3 different questions, and we're all working in the EV space, basically in the same direction. So if we can't come to a unanimous answer, you can only imagine what the confusion is that arises for the typical consumer. So there's a lot of education that has to take place from the manufacturer perspective. There's a lot of education that has to take place, also from the charging infrastructure perspective. It's just being educated and being able to weed out the misinformation or the disinformation, from what is the reality, what is the truth, and what best fits for each individual consumer.
Yeah, great. Thank you. Daniel Zuby, how would you answer that question about the top of mind, the biggest issues or opportunities in the EV space right now?
Yeah, I think the biggest issues are in making things smaller. And so I think cars and vehicles are too big. And most of 80% of vehicle trips are spent in one person driving by themselves in a car that weighs over 4,000 pounds. That's a huge source of wasted energy and a huge source of wasted money and space. And I think we need to right size the transportation. For example, if for every dollar of gasoline or electricity that you put into your vehicle, 98 cents of that dollar is spent moving the vehicle from point A to point B. Only 2 cents of that dollar is spent moving you from point A to point B. Because your vehicle is so damn big. Vehicles don't need to be so monstrously huge. We use a vehicle to move ourselves around. We don't use a vehicle to move the vehicle around. So I think we need to right size transportation.
Yeah, really, really interesting. If somebody who grew up in Europe, that definitely resonates with me. Cars are still a lot smaller in other parts of the world than they are here, for sure, right? I want to just I have a couple of questions that I'm going to pose to each of you kind of individually, just based on your backgrounds. So John, when we think about sort of the current state of the EV industry, the news is sort of full of negativity about EVs. Sales are down, they're not making money at the OEM level, technology is not reliable, demand is not where it should be. We've got, many new models coming out. I'd love just to hear your take on that as someone who's been in the large automotive industry world for many years.
Yeah, it's interesting because you're absolutely right. Recently, there's a lot of news, a lot of headlines, quite negative. Sales are down. You just said it yourself, Fiona, because that's probably what you've been reading in the headlines. It's a bit strange because if you look at the numbers, that's absolutely not the case. Last year, in 2022, EVs were about 5.8% of the percent of cars sold in the US, and right now it's at 7.9%. So on a percentage basis, it's increased, and in fact, 7% is typically a number used for technology adoption, where you reach a tipping point where the technology gets adopted even faster after you reach that 7% inflection point. And then if you look at actual sales numbers on a year-over-year basis, you have 50% increase in absolute numbers of EVs from last year to this year. So I don't understand what the sales decrease is. I think the better way to define those headlines would be sales are not at the pace that the automakers want them to be. Because the automakers are pumping out right now 36 new models just in the US alone. That doesn't even count all of the models that are being introduced in around the planet. So in the US, 36 models in 2023 alone, a lot of investment, and a lot of production. And to be honest, I think they have actually overestimated what the public is ready to soak up. So even though the growth is very fast, the production and the inventory buildup is slightly faster, unfortunately. And I think that's where this perception of sales are down is coming from. Again, it depends on use case. When customers are ready to make the jump into an EV, it's not ready or right for everybody. Everybody has their own use case. If you're a daily commuter to the same place, driving the same distance every day, and you don't make long trips, it could be the perfect solution for you, especially if you own your own home and can charge in your garage either overnight or once every couple of nights. So, again, it's all moving in that direction, and it will take time over the next probably 20 years to make this transition. Think about 100 years ago, the transition from the horse. People did not all buy a car in the same year in the early 1900s. There was at least a 20 to 30 year period where people made the change from the horse to the car, and we didn't have a Sunoco or a Exxon on every corner in 1920. That was something that happened later in the century. So again, the infrastructure is coming. It just takes time to get there.
I love that sort of historical perspective. So cool.
Yeah, to piggyback on that, Fiona, as well. I mean, I couldn't agree with John more. This is all data driven. It's quarter over quarter continues to look really good. I think, there's of course growing pains in this entire transition. And there's also, you can't just look at that one snapshot in time and say it's indicative of what the next decade will look like. Overall, it's a really positive trajectory, in my opinion. I would also say, there's key factors here that I think fully haven't been realized when we look at particularly the clean vehicle credits, the Inflation Reduction Act, the opportunity for consumers to, have even more of an ability of price parity with internal combustion engine vehicles with these credits. There's a lot of consumer education that still needs to happen in terms of what those look like, who's eligible, income thresholds, point of sale, transition of that credit, which will happen early in 2024 now. So, while that law has been on the books for over a year now, there's a lot of elements to it, I think, that have not fully been realized yet by consumers. And that's okay. I think it's going to take time, but I think we'll also see that help the shift as well.
Daniel, as you've talked a little bit about sort of the role that sort of government and sort of policy and lawmaking is playing in this transition, pairing with, what the automotive industry and others are doing. From a policy perspective, like in your opinion, what more is needed to help accelerate this transition?
Yeah, I mean, I know I may sound like I'm beating a dead horse here, but I can't emphasize enough the importance of domestic production when it comes to battery components and that work. There are some really forward-thinking policies that are incentive-based that were put forward in the Inflation Reduction Act. We have yet to fully realize those, I think, as a country, but you've also seen unprecedented announcement from battery cell manufacturing and automotive OEMs, of course, going 100% electric, within the next decade, but also announcing over 1,300 gigawatt hours of cell production here in the United States over the next 10 years. While that is super encouraging and I think necessary for global competitiveness, which will also help drive down costs for American consumers here, there is so much more work that needs to be done to actually supply that 1,300 gigawatt hour number when it comes to component thresholds and all that. So, I think overall, the United States approach has been an innovative one. I think the carrot model, so to say, over the stick here when it comes to incentives is an encouraging approach. I think we've really seen, private investment and manufacturing investment go in the right direction there. I think we have a lot to learn in the coming couple of years in terms of how that plays out. But I really think we need to stay the course in terms of, keeping our head down and committing to what these overall nationwide announcements look like and making sure we're actually supporting them with a localized domestic supply chain here as much as possible. And that's not going to happen overnight as well. Completely agree with John's opinion on this, but I do think, I think overall the United States is finally thinking about this in the right way and has taken appropriate action so far.
Yeah, super interesting. Daniel Zuby, you've talked a little bit about your own your own sort of new product that you're working on. But I'd love you to speak just maybe a little bit more broadly about what is the role of sort of innovation and sort of entrepreneurs in this space, like in addition to sort of some of these smaller modular vehicles you're working on, where else do you think there needs to be sort of innovation from a sort of product technology perspective to really support this transition?
Yeah, I think to echo what John had mentioned earlier, we kind of need to, it helps to take a step back and to think about what we're doing here, right? Back in the early 1900s, we changed the mode of propulsion of our vehicles from a horse to fossil fuels, to something you could put in the gas tank. And that really transformed our way of life for the better in many cases. But I think we're undergoing a similar transition here. We're moving from an internal combustion engine mode of propulsion to an electric mode of propulsion. And I think by just doing a simple copy and paste, by just, okay, let's rip out the ICE motor and let's replace it with an electric motor and call it good, right? We're missing out on a huge opportunity there. I think in order to really make the most of the electric vehicle platform, I think we need to rethink what it means to be a vehicle and redefine what a vehicle is. And I think the electric vehicle architecture can really change. I think we no longer need to think of a vehicle as something that's fixed, right? Something that is always going to have 4 wheels and an engine and always be capable of carrying 5 passengers at a time, right? Electric vehicles enable us to think of the vehicle as a dynamic, flexible system that can be changed depending on the number of people and the number of cargo, or the amount of cargo that needs to be transported from point A to point B. And so I think if we think of this in the larger context of changing the mode of propulsion, and then what other opportunities that lends itself to changing the design of the vehicle. And I think right now we're undergoing this transition, which is challenging, but I think it's supposed to be challenging, right? That's what happens when you change. I think if people are going to be expecting to change and it's going to be easy, well, you're kidding yourself. I think we need to be preparing ourselves for the challenge and meeting it with the right perspective.
Yeah, I love that. John, maybe you could jump in here. I mean, obviously you have the benefit of working outside the US for the last few years. What's happening globally on this point, around different modes of transport?
Well, it's really exciting actually to be here in Southeast Asia. I just actually spoke on a conference about 2 weeks ago where I met a lot of players in the 2-wheel and 3-wheel EV space. So just to put it into perspective, in the US, on average, there are about 15 million cars sold every year to a population of 330 million people, right? In Vietnam, you have 100 million people. So if it's a linear relationship, you should be selling around 5 million cars in Vietnam per year. They sell 300,000 cars in Vietnam. So there's a very low penetration of the automobile. And instead, in a population of 100 million people, you have 60 million registered 2-wheelers or motorbikes. Those motorbikes are now making the transition to electrification because as urbanization is growing in cities like Jakarta and Bangkok and Hanoi and Ho Chi Minh City, you have choking smoke because many of these motorbikes are still using a very low quality of fuel. So something has to happen. Indonesia has announced last year a big program of investment in electrification of 2-wheelers, either to convert existing ones from internal combustion or to have completely new electric 2-wheeler development. So just imagine in a country like Indonesia, right now there are 52 startup companies developing electric 2-wheelers. It's an incredible number. Vietnam has two companies that are developing electric 2-wheelers. I met people at 2 companies here in Thailand that are also developing electric 2-wheelers, and I'm also in contact with a company in India that's at the leading edge of developing the tuk-tuk, the 3-wheeler with electrification. Indeed, there are several companies that are producing those over in India. So there's a big shift. The transportation looks very different over here. A lot of things are transported by motorbike. It's amazing to see what exactly you can carry and how many people you can carry on a motorbike. But it's definitely something different than the US, and it just requires different solutions. But they're working very aggressively here to move into that electric future.
Yeah, so interesting. And we're going to take some questions from the audience here. And I'm actually going to go to a question that really speaks to that point, John, that you just made. It's a question from Kate Bashline. Do we lose safety in a smaller car, e.g. crash safety?
I think simple physics would usually dictate yes, that a larger car is going to win in an accident versus a very small and compact vehicle. That's normally the physics of it. And if it's a two-wheeler where you're exposed and you're not covered in some sort of safety cage, then that certainly puts you at a little bit more risk. But I think Daniel can probably speak to that as well, given that he is in that space developing something that he wants to keep people safe in.
Yeah, I know that simple physics, when you have a very heavy object and a very light object, usually the heavy object will win. But to think of it another way, when you have a very heavy, when you have a object that comes in, that crashes into a stationary object like a tree, it doesn't matter how heavy your vehicle is. In fact, you're actually worse off having a heavier vehicle, because that heavy vehicle is now crushing you as you're crashing into that immovable tree. And so I think you can design light vehicles to be safe. It's actually all about the strength to weight ratio is more important for when you're crashing into stationary objects. And I also think that the fact that there's large, heavy, absurd vehicles on the road shouldn't be a reason to not design smaller vehicles.
Yeah. Yeah, super interesting. Thank you. There's a question from Bill Babros on the other end of the spectrum. Is there an EV solution coming for heavy vehicles that have high on-demand requirements? For example, snow plows. He's obviously based in the Northeast where we are. Anybody want to jump in on the commercial vehicle side? Yes. Is there an electric vehicle solution coming for sort of heavy vehicles, commercial vehicles that have high on-demand requirements like snow plows? But I think you can speak to anything on the commercial vehicle side if you'd like to.
Right. There's a raging debate about whether large commercial vehicles should utilize battery electric technology or hydrogen fuel cell technology, and there are different ways to look at it. With fuel cells, for the passenger car, it's very impractical. You would have to build hydrogen stations all over. They're expensive. They are very energy intensive to create the hydrogen. However, when you're talking about commercial fleets, the trucks tend to go to the same location on the same route every single time. It's very predictable. So you can actually build energy hydrogen stations at very specific locations. The other thing is that batteries are extremely heavy. And if you have a truck combined with the weight of the load that it's carrying, suddenly you're starting to exceed the weight limits of the roads that you're driving on. So hydrogen is lighter. In that sense, you're just carrying a much smaller battery on a fuel cell electric vehicle. So you could carry actually more cargo and less battery weight with a fuel cell electric vehicle. So again, it always depends on the use case. There are definitely use cases for battery electric heavy trucks as well in shorter distances on extremely predictable routes.
No, that's great.
And
yeah, thank you.
I'd say on the technology space as well, I mean, regardless of the debate that John's mentioning, which I agree with, that's obviously currently happening, and what is use case. I mean, there is a lot of technology also going into medium and heavy duty deployment. I mean, if you look at Tesla's semi operation and work they're doing there, as well as a lot of money through the bipartisan infrastructure law, frankly, around fleet electrification, but also school buses, for example. I think there's a lot of research and development and work happening when it comes to medium and heavy duty. Whether that's been realized fully yet, of course not. But I think as battery technology also continues to improve, we will definitely see broader deployment in that space.
Yeah, really interesting. There's some questions here from Emma Cole. I'm going to sort of collapse them into sort of maybe one question for you. I'll put it to you, Daniel Zotos, actually. What do you think is a pain point in creating a circular economy, and how can it be bettered? And sort of second part of that question is like, what's the best way, in your opinion, to educate people about a closed loop economy, cradle to cradle sort of mindset?
Yeah, I'd say, I mean, initially, depending on various elements of the circular economy we're talking about, right? In 2024, I think in the United States, we're expecting about 250,000 EVs to reach end of life. That is all recyclable feedstock available to power future clean energy storage systems, future electric vehicles, et cetera. So, I think I wouldn't necessarily frame it as a pain point. I just think there's a scale, there's a graduated scale here in terms of end of life items and technology reaching a certain point in a broader sense to actually fully achieve that circularity, particularly to the transportation space as well. I'd say overall for circular economy, I mean, I agree entirely that there's so much more education that needs to happen. A tagline Redwood CEO in our company often, espouse in talks we give is the largest lithium and cobalt mines in America are in our junk drawers. And I think there's really something to be said about in aggregate, that we take for granted what, we have right in our hands here, and the technology and the critical minerals within them that we use each and every day. And I think, everyone can play their part. Maybe this is the grassroots organizer from New Hampshire in me, but I think everyone can really play their part in this transition as well when it comes to consumer electronics, when it comes to, of course, talking about what this means, but actually doing the work in terms of recycling and initiatives. So, speaking, personally on this, I'm a big fan of relational organizing and just sharing information and knowledge about this stuff. There's a lot of good resources out there, particularly on Redwood's website. But overall, there's also a lot of work that needs to happen with government investment, public awareness and education behind this, in better incentivizing, recycling channels and pathways. We've seen a lot of work in the EU around end of life batteries, smaller format consumer electronics, et cetera. So a lot of different ways to approach this one. But overall, I think there's a lot more that can be done when it comes to education around circular economy and actually digging into what does that mean? How long does it take to get there? And how can we all play a part in that as well?
Yeah, really interesting. Question here from the audience. We've seen some recent events, power outages in electrically heated and cooled houses in Texas and Oklahoma, resulting from stress on the grid during very warm or very cold weather. And that in many cases, the electric grid in the US is already not up to the existing demand. So is there any worry about the current electric grid being able to handle the larger load that more ubiquitous use of EVs will bring?
I always reach back again to the analogy of the transition from the horse to the car. It's not something that happens from one day to the next. So we're not all going to drive EVs in 2025 or in 2026. So it's going to be a probably 20-year transition. And so as the grid and as the utility companies are making that transition themselves, moving to ever greener energy sources, whether it's solar or hydroelectric or wind power, step by step, they're filling in those gaps as the demand coming from electric vehicles is stepping its way up as well. And there are many, many more home energy solutions that are available nowadays as well, where you can start to, number one, pull obviously solar energy from your roof to charge your car. And as cars start to have what they call vehicle to grid technology embedded in them from a software perspective, you can actually store energy in your car. And if you lose power, you can pull the energy back into your house to use it to power your house during brief power outages. So there's a lot developing, but I don't think we can expect it to all be solved overnight. Certainly not the grid. That's going to take decades.
Well, we are getting very close on time here, so I'm going to hand over in just a minute or so to my colleague Alexis Dwyer, but I'd love to have each of you, John, Daniel, Z squared, just have you just share like, a sentence or two of closing, which is about, what is one big takeaway that you'd like to leave the audience with today, perhaps particularly focusing on what makes you hopeful about the future of the transition to this new electric mode of transit. Daniel Zotis, why don't we start with you?
Well, given the theme I've thrown out there today when it comes to battery recycling, I mean, I will, and I know I just touched on this in the previous comment, but I am really hopeful and optimistic about the technologies we are deploying right now and will be deploying when it comes to battery circularity. I think there's something to be said about, every consumer really thinking about the opportunity and advantage they have in the devices or technologies they use and not taking that for granted either, but ensuring that, remains within the value chain as well, whether it be your EV battery or your smartphone. So I think, really understanding that and recognizing this shouldn't be landfilled. There's enormous opportunity to retain this value and power future generations of clean energy products pretty much infinitely is a pretty exciting thing in general. And it's something that we can all participate in. So I encourage people to, certainly look into what that means, look at Redwood Materials, overall in terms of the work we're doing, and also dig into your junk drawers. If you have, we often hold on to items thinking there's some sentimental value to them when there's actually no reason to just keep them sitting here or throwing them away. So I'd leave with that. We can all play our part.
Yeah, we're actually going to be doing a student and faculty staff and even local community electronic recycling push in the spring here on campus. So we should chat about that, Daniel.
Yeah, we should. I'd love to. Thank you.
Daniel Zuby, closing sentence or two from you.
Yeah, so I think I would just like to reiterate that we're at an inflection point here in the history of transportation. John had mentioned, the transitioning from horses to internal combustion engines, and now we're going to EVs. And I think the history of transportation, if you were to ask somebody in 1900 what it would look like, they would probably have no idea what we would look like today. And I think similarly, when you picture someone, when you ask someone today what the future of transportation is going to look like, it's going to look very different than it does now. And I think that's something that should give us hope, and I think it's something that is exciting.
Beautiful, thank you, John. Last words to you.
Sure. At the end of the day, I think personally that EVs are fun to drive. They have great torque. They feel more sporty in a way when you drive them. They're less expensive to operate, that you don't have to change the oil every 3,000 or 10,000 miles. They're much less expensive to quote unquote fuel. And ultimately they are cleaner if you're driving, for example, in cities. But they're not for everybody. And I think people need to consider, what are their individual driving habits? Are they driving the same route every day, every week? Do they have a varied driving patterns? Are they driving long distance? Are they just a commuter? Are they a traveling salesperson who goes city to city? Use cases will be different. Are you towing behind a car or a truck? So everything is different. So I think if you're interested in an EV, you need to do your research. You need to consider whether it's right for you. Does it meet your needs? You're not going to buy a hammer if what you need is a wrench. So you do have to consider, what is it that you need and how do you match that to your requirements? Because if you don't, if you buy the wrong thing, you'll be unhappy, of course.
That's great. Thank you. Well, thank you all so much for all the work that you're leading here and around the world, and for being fantastic UNH alums. Thanks for being engaged and sharing some of your wisdom with other people today. And it's now my pleasure to hand over to my colleague, Alexis Dwyer.
Thank you so much, Fiona, and thank you so much to our incredible panelists today. getting to be a part of the planning has been so much fun to be able to talk and meet with these experts and share them with you all today. So with that, I really hope that you join us for our next one on December 6th, where we'll actually be hearing from Dr. Paige Balcom. She's co-founder and co-CEO and CTO of Taka Taka Plastics. So definitely another one you're not going to want to miss. And we'll be sending out the registration for that, as well as you can find it by just Googling the UNH Alumni Sustainability Webinar Series. And of course, we would love to stay connected with you. So as Fiona had mentioned, I'm the Program and Network Stewardship Coordinator here at the UNH Sustainability Institute. And here are some different ways that you can stay connected. You've seen it, you can see it here on the screen. And if anything piques your interest, such as hosting a UNH Sustainability Fellow, attending UNHSI events, or perhaps you're interested in coming back to campus to speak with students, to share your experience, please reach out to me. You can see my email on the screen. I would love to figure out how we can get you connected. So thank you so much for joining us. Again, thank you so much to our incredible panelists. And just one more plug, you can see the bit.ly on the screen for our LinkedIn group. Hopefully you're already in it if you're a UNH alumni. But if not, search for the UNH Sustainability Alumni Group and request to join, and I'll be able to approve you, because there we share about these events and so much more, and having you in that group to share your experiences with everyone and network and see how we can further your work as well is something that we love to do. So thank you so much. Thank you so much to Daniel, and John. We're so grateful for your time. Have a great day, everyone.